Okay, so I welcome you once again to today's tutorial, which is on water, the chemistry of life, and we are basically looking at the properties of water, which is one of the most important and abundant molecules on Earth. The biology, which is the study of life, what makes the planet Earth to be inhabitable is the presence of water, among other things, and of course oxygen. And therefore, learning about water is very cardinal. So this is the topic that we're going to look at tonight. So water is the most abundant compound in living organisms, which makes about 60 to 90% of the fresh mass of all living organisms. It is quite important to living organisms, as it is an important chemical constituent of living cells, and it also provides a habitable environment for aquatic organisms. Central to its uses is or are the properties that it has, the physical and chemical properties, which are generally due to its small size, its polarity, and also due to the hydrogen bonding that occurs between water molecules and also between water molecules and other substances. So let us have an overview of the water molecule itself. So water, as we know it, it's H2O, 2 hydrogen atoms and 1 oxygen atom, which is basically dihydrogen oxide. So water has a neutral charge. It has no net charge, which means that it has an equal number of protons and equal number of electrons, equal number of positive charges and equal number of negative charges. However, the charges are not evenly distributed, and therefore, one of the property of water that comes from this description is its polarity. So water has a dipolar nature. So polarity is simply the unequal charge distribution over a molecule. So when you look at the molecule of water, you find that one end of each water molecule will bear a partial positive charge, while the other end will bear a partial negative charge, which leads to the uneven distribution of the electrons. So when you look at the oxygen atom it has 2 partial negative charges, as we will see on the diagram that I will show, while each hydrogen atom has only 1 partial positive charge. And because of the 2 non-bonding pairs on the oxygen, because of those 2 non-bonding pairs, they remain close to the oxygen atom, and then that leads to a strong repulsion forces or repulsive forces, which leads to them being pushed outwards or closer to the hydrogen atom. So the hydrogen atoms draw closer to each other, which leads to that special angle of 104 degrees. So that's the picture, which is showing the electron distribution. You have those 2 free electrons on the oxygen, which exert repulsive forces, which leads to the hydrogen atoms to be pushed towards each other, leading to the formation of the 104.5 degree angle. So you have the two partially negative charges on the oxygen there, and then you have the partial positive charge on the hydrogen atoms, which leads to a dipole or a dipolar nature of water. So dipole nature of water due to its polarity. And then the other important property or chemical property of water is its unique feature to form hydrogen bonds. So hydrogen bonds are simply relative weak bonds formed when a hydrogen atom with a partial positive charge. So a hydrogen atom with a partial positive charge is attracted to another atom. So usually the atom is oxygen or nitrogen, which has a partial negative charge already bonded to another molecule or in another part of the same molecule. So you find that these hydrogen bonds can be formed between oxygen atoms of water molecules and hydrogen atoms of different molecules, such as acids. Can also form between hydrogen atoms of water and hydroxide groups of other molecules, such as alcohols. And of importance for today's discussion is the formation of hydrogen bonds between oxygen and hydrogen atoms of different water molecules. So when we look at the water molecule, it is associated with hydrogen bonds. So basically, when we look at the liquid state of water and also the solid state of water, we find that water is associated with hydrogen bonds. The hydrogen atom of one water molecule with its partial positive charge is attracted to the oxygen atom of a neighboring water molecule with its partial negative charge, forming a hydrogen bond. An oxygen atom in a water molecule, as I explained earlier, has two regions of partial negative charge, that is on the oxygen, and each of the two hydrogen atoms has a partial positive charge. So we find that each water molecule will therefore form a maximum of 4 hydrogen bonds between itself and the neighboring molecules. And these are formed in the solid state. The maximum number of hydrogen bonds, those 4 are formed in the solid state, as we'll see further. So we can revise on the states of matter. The states of matter. So water can exist as a liquid, can also exist as a solid, and also as a gas. So when we look at melting, which is simply the change of matter from solid to liquid. We also have freezing, which is a change of state of water from liquid to solid. And then you have evaporation, which is a change of state of matter from liquid to gas. You have condensation, which is change of state of water from gas to liquid, and deposition, which is a change of state from gas straight to solid, or sublimation is a change of state from solid to gas. Now, this state of matter are very important because certain things happen for water to change from one state to another. And these can be explained due to the hydrogen bonding that we've already talked about. So the hydrogen bonding explains the way water responds to changes in temperature. So when there's a change of state, it's either hydrogen bonds are broken or they are formed. Either the hydrogen bonds are broken or are formed. So for example, when we raise the temperature, we add heat. We raise the temperature by adding heat. And heat is a measure of the kinetic energy. It is the measure of the kinetic energy of a substance. So for the temperature to rise, the kinetic energy of the water molecules need to increase. In other words, the water molecules need to move faster. So there should be an increase in velocity. Now, in the water molecules, for them to move more freely, some of the hydrogen bonds of the water need to be broken. So when you add heat, when you raise the temperature, there will be breaking of hydrogen bonds. However, you find that much of the energy that is added to the system is used up in breaking the hydrogen bonds. And hence only a portion of the heat energy is available to speed the movement of the water molecules, thereby increasing the temperature of the water. Conversely, when liquid water changes to ice, there is addition of hydrogen bonds that are formed, making the molecules less free to move and liberating a great deal of heat into the environment. So basically we are saying when we add heat, when we are trying to raise the temperature, there is breaking of hydrogen bonds. When we are lowering the temperature, when we are changing water from liquid to ice, there is additional formation of hydrogen bonds. Therefore, this leads to a property of water of high specificity. So water has a high specific heat capacity. So specific heat capacity is simply the amount of heat measured in joules that is required to raise the temperature of 1 kg of water by 1 degree Celsius. So water has a high specific heat capacity, because when a source of energy is applied to it or to the system, that heat energy will first be used to break hydrogen bonds before that heat can be transferred to make the water molecules begin moving faster. Therefore, we need a large increase in heat energy for there to be a rise in temperature. So, a large increase in heat energy will result in a relatively small rise in temperature. What is the importance of this? So we find that biological systems, biochemical reactions in our bodies are maintained in a relatively constant temperature, or what we know as homeostasis. And then what also has a high heat of vaporization, which is simply the amount of energy required to change 1 gram of a substance from the liquid state to the vapor state. As in high specific heat capacity, water has a high heat of vaporization because of the hydrogen bonds that hold the water molecules together. Therefore, it has to take a large amount of energy to break the hydrogen bonds in liquid water and change the molecules from the liquid phase to the gas phase. As a result, water has to absorb a great deal of energy for it to evaporate. So for water to vaporize, when we apply heat, that firstly the heat energy will go to weaken the hydrogen bonds, and then that's when it will lead to faster movement of water molecules, changing it to the gas phase.
Sir, Those they are making noise. Those who are speaking in the background, tell them to mute their mics.
Okay, thank you. Okay, thank you. One other property of water is the liquid state of water is more dense, or is denser than the solid state. So remember, I mentioned that water forms a maximum of 4 hydrogen bonds at one time in the solid state or in ice. So you find that each oxygen atom can form 2. Remember, oxygen has 2 partially negative charges rather. Hence, those partially negative charges on oxygen can form 2 hydrogen bonds. And then each hydrogen atom can also form 1, which leads to a formation of a total of 4 maximum hydrogen bonds. So in ice, those hydrogen bonds causes the water molecules to form a regular and repeating structure, or a crystal. So this crystal is fairly open, meaning there's a relative large amount of spaces between the molecules. So the extent of hydrogen bonding in liquid water is much less than that found in ice, and that the hydrogen bonds in liquid water are constantly being formed and broken. So when you look at the liquid state of water, it cannot form the maximum number of hydrogen bonds, which is 4, because the hydrogen bonds are constantly being broken and being formed, which is not the case in the solid state. So this leads to the molecules being tightly packed in the liquid state than in the solid state. So when you look at, when you heat a substance, normally you find that when we heat the substance has to expand. The molecules have to start moving faster and colliding more often and with a greater force. However, when we heat ice, heating ice will cause the hydrogen bonds to break, and then this will lead to the opening of the crystal structure to collapse. In this way, we are able to explain how hydrogen bonds leads to liquid water being more dense than solid, which is a very important property, especially when you look at aquatic life. So we find that ice can form at the surface of the ocean. So ice can form at the surface of the ocean, whilst aquatic life is preserved under the ocean. So this is the biological significance of liquid water being more dense than solid or ice. The other properties of water that we need to consider are cohesion, adhesion, surface tension, and capillarity or capillary action. So when we look at cohesion, it's simply attraction between similar molecules. So cohesion leads to the sticking of molecules, same molecules or similar molecules. For example, attraction between water molecules, that's cohesion. So water molecules have a strong tendency to stick to one another. So because of the cohesive nature of water molecules, any force that is exerted on part of a column of water is transmitted to the column as a whole. So one water molecule will be attracted to another molecule, to another water molecule, which will further be attracted to another water molecule, and they form a chain. Therefore, any force that is applied to one water molecule is transmitted through the whole column of the water. This is very important, especially when you look at the movement of water in plants in the vascular system, the xylem of the plants. That water moves through the process of cohesion. Cohesion as a property of water also leads to the formation of what is called a surface tension, which happens at the surface of a liquid or at the surface of the water. So remember, at the surface of the water, you have water molecules at the surface, and then you have water molecules downwards. However, on top of the surface, you have air. So you have the air-water surface there. Therefore, those molecules that are at the surface will be drawn downwards by the water molecules that are down. And then this will lead to the formation of a skin-like surface at the water level there, which is what is known as surface tension. So surface tension is important, for example, when you start looking at insects that are able to move at the surface of the water. It is also important when you consider the life cycle of mosquitoes, the larva stage. Remember that mosquitoes breed in stagnant water, all because of the property of water of surface tension. The other property of water is adhesion, which is simply attraction between unlike molecules. So usually adhesion is analyzed when you look at an interaction between a liquid and a solid surface. So water adheres to surfaces that have a polar or a charged component. So for example, if you put water in a glass cup, that formation of the meniscus of water is explained through the force of adhesion. So adhesion takes place between the water molecule and the glass or the cup. And also this also explains why water makes things wet. Water makes things wet because of the adhesive forces that takes place between the water and that thing, for example, a cloth. Then you have capillary action or capillarity, which simply comes because of the adhesive and the cohesive forces. So capillary action is simply the tendency of water to move in narrow tubes, even against the force of gravity. So for example, water can move through the microscopic spaces between soil particles to the roots of plants by capillary action. Then another property of water is water as a solvent. Water is termed as a universal solvent. So you find that water is going to dissolve hydrophilic molecules or water loving. So hydrophilic simply means water loving. Because water has a slightly negative charged oxygen, as we have looked at, and a slightly positive hydrogen. The slightly negative oxygen will attract positive ions or the cations, and then the slightly positive hydrogen will attract the anions or the negative charged ions. So you have examples of things that they can dissolve in water, such as sugar, same table sugar or sucrose, and table salt or sodium chloride. Some of the examples of substances that are able to dissolve in water. And then we have non-polar or hydrophobic or water-hating molecules such as lipids or fats that do not dissolve in water. So this diagram simply shows, see sodium chloride. The diagram on top is showing sodium chloride, the interaction of sodium chloride or salt with water. Okay, so you have the partially positive hydrogen and the partially positive oxygen. So what will happen is that the hydrogen, the partially positive hydrogen atoms will surround the chloride ion, to surround the chloride ion, while the oxygen, negatively charged oxygen, will surround the positively charged sodium ion, which will lead to the dissolving of the salt in water. However, when you look at hydrophobic substances, such as lipids, you find that since they are not attracted or they do not form any hydrogen bonds, they are going to aggregate. For example, the formation of micelles. So you have the hydrophilic part, which is the head, and you have the hydrophobic tails. So the hydrophilic heads will form bonds with the water molecules, or will be oriented towards the water molecules, while the hydrophobic part will orient themselves away from the water molecules. So this is very important, especially when you start looking at the structure of the cell membrane, which is made of phospholipids. If the cell membrane was made of a hydrophobic substance, this would lead to cells dissolving. But because it's made of a bilayer of phospholipids, this protects cells from dissolving. So in summary, when we look at the unusual properties of water that we've looked at, we've looked at water being a universal solvent. Water being a universal solvent, which is what we are just from explaining. We've looked at water being polar, it having a positive and a negative charge end, which leads to the formation of hydrogen bonds. And then we've looked at water sticking to itself, which is cohesion, attraction between water molecules. And then we've also looked at adhesion, which is attraction between water molecules and other materials. We've also considered high surface tension, which simply is a property that comes through the forces of cohesion, which leads to a formation of a skin-like layer at the surface of the water. And we have also looked at ice being less dense. We've said that water expands when frozen. Therefore, it leads, the density of ice is less than the density of liquid water, which leads to the ice floating, which explains aquatic life being able to survive in the ocean under the ice. So let's remember the properties of water. The importance of hydrogen bonds to the properties of water, the polarity of water, the importance of high heat capacity of water, the importance of heat of vaporization of water, such as the cooling effect, the biological significance of the high heat of vaporization. One of them is the cooling effect. We are able to cool our bodies through the process of the vaporization. When you look at the temperature range between melting point and boiling point, it's 100 degrees Celsius. The reason to this is that when you heat the water, when you apply heat to the water, you need a large amount of heat to change or to increase the temperature of water, because initially that heat energy that is applied goes to break the hydrogen bonds between the water molecules. Afterwards, then energy can now lead to the faster movement of water, and henceforth temperature can increase. Remembering that temperature is the average kinetic energy of the molecules. Okay, so this is where our tutorial ends. Are there any questions?